scalable human-computer interactions. What is that? How it will scale, the human-computer?
The way that I look at how you sort of remove friction here is you need to build systems that do three things. They need to be interactive, they need to be familiar to the user, and they need to be expressive, right? Where expressive sort of encompasses efficient. Like basically, you need for the human to be able to sit down and know exactly what they're looking at. They need to be able to keep up a train of thought. So like our target for our systems, which we sometimes hit, sometimes don't, but our baseline is about 10 seconds is what we're looking for in a response time. Like anything longer than 10 seconds, people start to wander off and check their email, look at Facebook, whatever it is. And this is something that you actually see in sort of the flow of like big data systems today. Like if you look at something like Hadoop, if you have a sizable Hadoop cluster, even like a trivial job that does like nothing, takes like 3 or 5 minutes to run. And that just has to do with all the machinations around the scheduling and the dispatching and whatnot. But that's too long to wait between questions when you're a human analyst, right? You want to be able to keep a train of thought. So the way that you make it scalable is actually by doing all of the hard engineering that you need to do this, right? Which I know is a little bit of a cop-out, but I'll give you an example. So this was not actually in the workflow that I showed, but we have a piece of technology that we built from scratch called Horizon. And the idea with Horizon is that it's kind of like MapReduce, but it has no intermediate result. And what we did is we built just a very, very carefully optimized, distributed in-memory, I guess it's like a column store of all the data in the system. And what it actually lets you do is we can actually move over billions of records in interactive time. So you can like compute the average and the median or filter down to a smaller set, literally in under 10 seconds over billions of records, right? And it was a hard engineering feat to do that. And It's something I'm proud of our team. So we have some very fearless engineers who are like, well, no one's built this, guess we're building it, right? But once you have that, it actually lets you do workflows that you couldn't do without it. And so there isn't like the problem with this question, well, not with the question, but the problem with the answer, I guess, is that there isn't one answer to it, right? And like one way to think about building technology in general, and the way that sort of traditionally the way that technology companies approach technology problems, is that they find one thing that they're good at, and then they optimize the hell out of it. They're like, we're going to build a relational database. Here it is. We're going to make it bigger and faster and more expensive over time, which is optimizing in many directions at once. But that's all we're going to do. And we don't care about what you're going to use it for. It's good for this abstract thing. It'll relate your data. And that's all it's going to do. And you have to figure out how to use it. And so it's up to sort of the other technologists who are going to take it and deploy it against problems to figure out how to make it work. What we've done is we've kind of turned that on its head. What we said is what we started with is actually the user problem first. Yeah. Which is we're looking at it somewhat we're looking at a whole class of problems. So there's many different problem areas, but it's the same approach that people take. In the same way that Photoshop can use from many different types of pictures, but the sets of tools that you use to do that are all the same. And so there are things that you can only do in our user interface because of something that the backend knows how to do. Right. And so the real answer is you just got to figure out what it is you're trying to do and then engineer your way into a solution, right? And there's no other way through than to just keep iterating until you've actually built the thing that solves the problem.
Okay, so we'll move on to the next question. Can you comment on the privacy implications of gathering and processing all this private information?
Yes, absolutely. So, I mean, first of all, in some ways, we sort of sidestep the issue in that we're a software company. We don't actually collect any data whatsoever. We don't have any data at all. We just build software that if you have data, you can use to process it. But that said, we actually think really hard about the privacy implications of this because often what we see is there's kind of a false choice that people are given between building systems that protect people's privacies to the utmost level that they can and letting people do their work. So often when you see things that need a lot of data sharing, people are like, well, you just have to give us all your data. And then we're going to figure out what we need to do with it. You have to trust us. And then we're like, there's probably a better answer to that. And so we've done some things. We've engineered some things into the platform specifically to address this. So, your sort of typical permissions that you have in a data system are read, write, and owner, where owner can grant privileges to other people. Read, you can read, and owner, or write, you can change it. We've added in a fourth permission called discovery that our security model implements. And the idea with discovery is you can take some amount of data and put it, make it available to a group of users where they can search against the data, but they can't actually see the data if there's a result. So if they search, they get back a result that says, there are results that matched your search. Go through this out-of-band process to get access to that data. So in a medical context, that's getting patient consent, right? In a law enforcement context, it's getting a warrant. In an intelligence context, it's justifying need to know. But the idea is that if the data is in the system and you need to find it, you should be able to find it, but you shouldn't be able to abuse it by looking up your ex-girlfriend or something like that, right? So, and we actually have a whole team of folks that we call the privacy and civil liberty engineers. They are mostly actually a bunch of lawyers, but they think really hard about what the different implications are. And so, you know, we've been looking at different applications. We haven't done anything with this yet, but we've been looking at different applications in looking at large amounts of social media. And like we basically have like an advisory board of law professors who look at these kinds of things as well. When we convene them and we ask them questions like, let's assume you have a bunch of social media data that you've gotten legally, like you're looking at like tweets or something like that where you haven't violated terms of service or anything like that, but you want to start drawing insights from it. What are the legal implications? And like in this particular example, the conclusion they came to is there aren't any legal implications. You can kind of use them for whatever you want, but everyone's going to think it's really creepy, right? And so what we try to do is figure out what features do we need to put into the platforms that remove that false choice between privacy and effectiveness or security, right? Sure. And we don't know all the answers, but we're willing to sort of dwell in the gray area and figure out what the right way to do it is. But we don't collect data, so we kind of, it's much more theoretical for us and about the technology.
I'm sure you're supporting many different applications for your customers. When you think of that collecting private data and make that to be useful, what is the best or the top application that you think of for a good cause that you can share?
In terms of collecting data?
Collecting and using that for a good use, best use case that you have seen.
Well, okay, so one of the things that we do is we have a philanthropic team. So rather than sort of doing corporate charity by just giving money to people, we've decided that the best way for us to sort of give back is to do the thing that we're most uniquely suited to do. So we have a philanthropic team, and what we do is we go look for nonprofits that have data about interesting problems out in the world. And so a couple of them that we're working with are NCMEC, which is the National Center for Missing and Exploited Children. And they're basically the people, like if you're a sheriff and you get a child abduction, you call the National Center for Missing and Exploited Children, you say, I've got a missing kid, what do I do? And they have a whole recipe of how you run through like setting up roadblocks and doing all this stuff. So they've been using our software, they've been using it to look at old cold cases and sort of reopen those and been able to solve some of them, as well as reducing the response time when in this sort of 72-hour window that you have in sort of a fresh child abduction case. Another one that's actually much more, there's nothing bad about it, there's nothing evil, you know, you're not even fighting evil, is a foundation that we're working with called the Grameen Foundation. And they're actually really at the leading edge of using smartphones to engage with sort of the poorest groups of people in the world. So, and they specifically have a program in Uganda where they've hired about 1,000 people that they give these smartphones to, or they actually sell them sort of buy them through their salary. And they hire them to go out and talk to rural farmers. And when they meet a farmer, they sort of register them on their phone and they have them go through, they fill out a survey about their demographics, you know, and it's these questions that are just, they're a little heart-wrenching when you sort of think about this. It's like, how many children under 11 do you have? Do your children have clothes? Do your children have shoes? Do you have mosquito nets? Do you own a watch? Right? What do you use as cooking fuel? Right? And also, like, what livestock do you have? What sort of crops do you have? And they gather that information just to get a demographic snapshot of who they're talking to. But what they offer in return is whatever information you need to know about agriculture. So they actually load an entire database of agricultural information onto the smartphone. And you say, well, you know, my chickens have been getting this whitish stuff on their beak right after they're born, and then they have diarrhea, and then they die. What's going on? You know, the work that we've been doing with them is actually looking at that data and looking at the query data. And what we were able to do very quickly was come up with, find actually both crop and livestock disease outbreaks, which was not part of the intended purpose of the data, but like as soon as you put it in a platform like ours, you're like, hey, look, woo, it blooms, you know, and you're like, hey, there's a problem over there, you should do something with that.
Right, that's exciting.